Okay, I'm going to start this live stream now. So what has happened is we've got snow out here in the Fraser Valley, and it just wouldn't be safe or prudent for me to get into BCIT tonight and traverse those roads. So I am going to go through the content of our notes tonight, and this will be up on YouTube later for you folks to review and go through and follow along. So first of all, let's have a look at the notes for tonight, and we're going to go to the S1.01 coordinate systems, and we're going to talk about Revit's two coordinate systems. Now these are coordinate systems that might have been unknown to you before, and maybe you knew about them, but we're going to go through them now. Now to see Revit's coordinate systems, which are normally hidden from you, you have to turn on these categories to make the origins of these coordinate systems visible. So in the visibility dialog box, the icons for these coordinate systems are stored down under the site category. So if you expand the site category, the first icon, the first origin that we're going to look at, is the project base point. So the project base point is a round icon that has an X through it, and you can see it here on the screen. This icon is truly the Cartesian 0, point for Revit. Internally, Revit uses this icon as the starting point for all of its calculations. So when Revit is calculating the length of a wall, it uses this icon as its starting point. Now it's also important that you build your model within 10 miles of this icon. Now this has to go back and talk about something a little bit technical, and it has to do with some of the components of the Windows operating system. So Revit, like AutoCAD, has what's called floating point precision. This means that Revit is able to represent our buildings and our projects with almost infinite accuracy. But the software requires that you still build your project within 10 miles of the project base point icon. And the reason for this is that Windows graphics technology, which is called DirectX, has a finite number of digits with which it can represent the vectors, curves and lines on your screen. So if you start getting into these greater distances, the accuracy with which Windows can display those objects decreases. So that's why it's important to keep your projects within 10 miles of this icon. Now, the coordinate system that Revit uses and that is associated with this icon is called project coordinates. So if we go back and look in our notes here, project coordinates refer to your project, and you don't really have to worry about where your project is and where you start drawing your building with respect to the project coordinates icon. Now, on many projects there is a need to have a location on the project that is a starting point or a point of reference for all of the consultants on the project. Now, generally speaking, the project base point, which is the 00 point for project coordinates, is not used for that purpose. The developers have appointed another coordinate system called shared coordinates, which can be used to create a point of reference for use by all of the consultants on the project team. So if you go into the visibility dialog box and again scroll down to the site category, this time we're going to expose the survey point, and I'm going to turn the project base point off. Oh, I see we have one more subscriber on there. Listen, I see that you're on the stream here. Is there any chance that you can give me a call? Okay, the speakers on the computer aren't very good. Can you try turning up the volume? I can try turning up the volume on my end here as well. Okay, I've turned up my volume here. Does that make it a little easier for you folks to hear me? So you should be able to turn the sound up. Okay, good. Thank you. That's right. Yep. Someone should be able to log into the computer at the front of the class just with their student number and their ID, and be able to get in and get to the YouTube channel. So here I will give you the link. Actually, if you just go to youtube.com/Wes Macaulay, that's MACAULAY, you should be able to get this up on the big screen. So I'm just going to put my cell phone number up here so someone can call me if they need to. So you can either use the live chat window in the YouTube app, or you can text me directly to my cell phone number, which I put up on the screen there, and we can try and get along using that method. Yeah, sorry folks that I couldn't make it in tonight. The roads are absolutely deadly out here in the Fraser Valley, and just decided that it wouldn't be wise to try and get out in the roads there. Hey, you got me on the big screen now. Okay, the question is, can you hear me clearly enough? You can adjust the volume just down on the Windows taskbar there to try and get the good. All right. So anyway, if there's any questions, just text the questions to my cell phone number there, 778-823-3913, and we will proceed with the lecture here remotely. So in the share out folder for tonight, we're going to be looking at the PDF. So that's session 1.01. So we're looking first of all at Revit's coordinate systems. So I've got the Word document up here on the screen, and you folks can refer to the PDF as we go. So we've talked about project coordinates, and now we're talking about shared coordinates. So the icon for shared coordinates is the survey point icon, which you can see we've got the triangle located here, and this can be the shared point of reference for all consultants on the project. So if you happen to have drawn your building, and it doesn't really matter initially where you draw your building on the screen, you can just get your building out there, and then when you're done, at some point when you want to create a point of reference for your team, you can turn on the survey point and simply use the move icon to move it to a location on your site. So you could move it to a grid line intersection, or you could move it to a property line corner. All of those would work. And so what can happen is all of the Revit files and AutoCAD files can be made to relate back to this icon. Now, not only can we move the survey point in plan, we can also move it in elevation. So here I'm going to go to my south elevation, and I'm going to go to my site category, and I'm going to turn on the survey point. Now, what the survey point is often used for is to indicate the project's elevation above sea level. So oftentimes when we get started on a project, we will make the main floor of the building 100 feet above sea level. So we'll show a relative elevation of 100 feet for our main floor, and then 110 feet for the second floor, and so on. Now, that will still not tell us what the building's height is above sea level. So for instance, if our building is say 59 meters above sea level, I can grab our survey point here and I can move it down 59 meters. And you'll see that the survey point has indeed moved downwards. So this can help our building relate back to its height above sea level. So shared coordinates are used to relate our main building, or relate our building to geodetic elevation. So that is the height of the building above sea level. And it's also used if we need to relocate the building horizontally in any for any reason. So if the building needs to be relocated on site, in Revit it's quite difficult to grab all of the geometry of your building and move it horizontally, or move it anywhere in plan. So to grab your entire model and move it around on your screen because you need to relocate it on the site is quite difficult, and you generally don't want to try and make that work. So what it's actually easier to do is to grab your survey point, which represents a point on your site, and move that instead. So there's the old adage that it's easier to move Muhammad than it is to move the mountain. So it's easier to move the site. In this case, it's actually easier to move the mountain than it is to move Muhammad. So it's something that we'll be talking about in more detail later on tonight, because we'll be talking about how to set up our projects, and to set up a site model, and to set up a model for our building, and actually have them in two separate files. Okay, so we've been looking at the coordinate systems icons, so we're moving on to page 2 of the notes. And first of all, we're going to look at this survey point. So when I select the survey point, you can see that there is a paperclip icon, and you can see that there are two axes on this icon. There's a green axis which points towards north, and there is a red axis which points towards east. So you can see we have an east and westing and a north and southing on the icon here. Now, generally speaking, when you work with the survey point, you're going to locate it in its clipped mode. Now, you'll notice that there is, when you click the paperclip icon, it puts a slash through it. Now, if we do this, we can relocate the survey point icon in the unclipped mode. And now you'll notice what's happening. So what this does is it does not relocate shared coordinates itself. It simply relocates this icon. So what we have now is the origin of shared coordinates, which is down here at the original location of the survey point. But because we unclipped it, it moved into this mode. Now, this mode is actually only used by a program called Civil 3D. So folks, whenever you move the survey point around, please keep it in the clipped mode. So here what I'm going to do is I'm going to move the survey point back to its location by clicking on the north, south, and east, west icons, and making the amount of displacement between the survey point and the origin of shared coordinates 0. So what I'm going to do next here is I'm going to go down to the site category, and I'm going to turn on the project base point, and you're going to note that there is deviation between the location between these two sets of icons. So when you click on the project base point, you can see its north axis is being shown, and you can see that the survey point has its own north axis as well. Now, this brings us to another function of shared coordinates. Shared coordinates are used so that the building has a coordinate system that points towards geodetic north. Now, on most of our projects, we have a project north, and then we have a true north, which quite often points in a different direction. So if we do have a true north, what we can do is rotate our shared coordinates so that they will point to true north. So what would happen in that case is that the axes of our survey point would be rotated such that the green axis here on my survey point would point towards true north. So to do that here, I can click on my project base point and I can indicate, what the declination between project coordinates and shared coordinates is with respect to true north. So there might be a 9.63 difference in angle between the two coordinate systems. So when I do that, you can see that nothing's changed in my drawing and nothing's changed with project coordinates, but you might have noticed that the survey point shifted, and you'll also notice now that the green axis of the survey point is pointing in a new direction. So what we have now is that our shared coordinates are pointing towards true north. So there's two ways that you can set up your true north. One of them is by, oddly enough, clicking on the base point and indicating the angle of deviation between your project north and true north. So that's one way of doing it. And another one is by having a surveyor's north arrow in your drawing. So what I'm going to do here is I'm just going to draw a line that indicates the direction to true north. So just a line on a random angle like so. And so what I'm going to do here is I'm going to set things back up the way they were before. It's going to set the angle to true north to be 0. So now you can see that our project coordinates and our shared coordinates are both pointing in the same direction. Now on the Manage tab, we have a tool in here that will allow us to rotate true north graphically. So instead of putting in an angle value, here we can use a graphic north arrow that's provided to us by our surveyor, and we can rotate shared coordinates so that the north axis of the shared coordinates icon, the survey point, will point in the same direction as this line. Alright, so here we go. So I'm going to grab the tool here. It's called Rotate True North. Now, Revit comes back and says your views must be oriented to true north. Now, this is a setting that you've probably not paid attention to before. And if we go over and look in the Properties palette, you can find the orientation parameter. And it says Project North. So, what I need to do here is switch the view to true north. Now, after having done that, nothing happens. So here, because our survey point is still pointing straight up on the screen, there is no change in our screens or in the plan's orientation. But now that I've changed the orientation parameter for this view to true north, I will be able to use the Rotate True North command. Now, what Revit wants me to do is to indicate indicate the direction of rotation. So what's happening, if we can describe here, is we're saying to Revit, this is true north right now. This is where we want it to be. And by doing that, you can see it's rotated the screen in that direction. I'm just going to undo that. But what I'm going to do this time is I'm going to move the center of rotation to my cursor. So you can hit the space bar, or you can hit the place command up on the top of the drawing area, and you can see it moves the axis of rotation to my cursor, and I would move that to the south end of my surveyor's north arrow. So that's number one, the first step. The second step is indicating where true north is right now. So here we're going to put it along the surveyor's north arrow, and we want to say that we're rotating it so it's straight up on the screen. So you can see what's happened. So let's go through that one more time. To rotate true north using your surveyor's Cad file, which you would have imported and moved and rotated into place, use the Rotate True North command, hit the space bar, and put the axis of rotation at the bottom of your surveyor's north arrow, at the south end. Then click the north end of the surveyor's north arrow and rotate it so it is straight up on your screen. And what this will do, it will orient this plan to true north. Now you'll notice that I can go back to the orientation parameter and switch it to project north. So now in any plan view, and of course most likely just in your site plan, you can show the building in its true north orientation. And then of course for most of your working drawing plan views, you will keep the orientation to project north. Now again, if you have any questions or if you're confused by anything, just send a text message off to me, or you can put a note into the YouTube stream box there, into the chat box, and I will answer your questions as they come in. So I'm keeping an eye on those here, and I'm keeping an eye on my cell phone if any questions come in. Okay, just back to my notes here. Okay, so what we're going to do right now is give you folks a chance to give this a go for yourselves. And what you're going to do is find the term project file in the term assignment folder. So I am going to open up that file here right now myself, so you can have a look up on the screen and see how this is going to work. So you would find this file in BLDG 2805 and then in the term assignment folder. Okay, so this, I've only got the 2015 format version of the site's file at home, but we're just going to upgrade it here. This will take a few moments and then we will proceed. Hopefully you folks are still able to hear me clearly there without any distortion. I know my laptop cooling fan blows once in a while and may interfere a little bit with the sound, but it's pushing the stuff up to YouTube, so it's having to do a little bit of work tonight. Okay, so the folder that it is in, you folks will have to look for in Windows Explorer. So if you hold down the Windows logo and then tap the E key, it will pop up a copy of Windows Explorer, like you see up on the screen here. And then over on the left, look for My Computer and expand that, and then you will see a J drive. And from there you must go to Share Out, or J, BLDG 2805, and expand that and look for the term assignment or the term project folder. So I'm just going to look it up here remotely and just confirm the name. Okay, so it is the term assignment folder, and inside that open up the site model 2018 file. Site model 2018. So once you've opened that up, you should be able to see what I've got on my screen here. So I'll just wait here a couple moments and then we'll get started. Now the first thing that we need to do the rotate true north command is we need to take this particular plan view and set its orientation to true north. Now, as you can see, nothing has happened. But here we've got a north arrow down at the bottom of the screen here. So this came from the surveyor, and that north arrow is not yet pointing straight up on our screen. So we must use the rotate true north command to get that arrow pointing in the right direction. So we're going to go to the Manage tab, and under the Position menu, we're going to choose Rotate True North. So now what we're going to do is we're going to hit the space bar to move the axis of rotation to our cursor, and we're going to go down and pick the south end of the north arrow. That's click number 1. I'm just going to zoom in a bit here. So there's click number 1. Click number 2 is the north end of the north arrow. So there's click number 2. Now click number 3 is just to rotate that arrow slightly counterclockwise so that it is pointing straight up on the screen. So now when we have a look, we can see that indeed our north arrow is pointing straight up on the screen. So we have successfully rotated shared coordinates so that the north-south axis of the shared coordinates icon is pointing straight up on the screen. And you can see that it looks like our plan has been rotated as well. Okay, so what we're going to talk about next here is in the next PDF here. It's called the Project Setup PDF. Now, this talks about relative elevations on your project and how you should set up your project initially so that you can make use of a main floor elevation of 100 feet. So there's some instructions here which we are going to go through now and show you how I would recommend that you set up a project. So this would be something that you could put into your template or into that you could just implement on an on-the-fly basis. Now, the instructions here depend on whether you are doing your project in metric or in imperial. Now, in either case, if you're working in imperial, you need to set it up so that your main floor is at 100 feet. If you're working in meters, you want your main floor to show 100 meters. So again, this is just a nice even number for contractors to see for the main floor of your project. Now, the reason we want to do this is if we have any floor levels that are below the main floor, we don't want those numbers to be negative. So if our main floor is at 0 and we've got 3 underground parkade levels, we don't want the elevation values of our parkade stories to be negative numbers. That just creates confusion for our contractors. So what we do instead is show 100 feet of relative elevation for our main floor, so 100 feet, and so then our parkade levels would be at 90 feet and 80 feet and 70 feet and 60 feet and so on, and it's much easier for the contractor to work with those sorts of numbers. So what you need to do in Revit to enable that same feature, and what I'm going to do now is you folks can save as this site model to your own computer, or if you've got a flash drive, save it to that, and then we're going to do this setup function for our projects in about a minute. Okay, so here we're going to be working with some of the functions of Revit's coordinate icons to allow us to have a main floor elevation of 100 feet. So if you folks could just open up the south elevation of even just the architectural template, we can use that as a starting point for this next part of the exercise. Now you can see I've got my survey point that I moved downwards, but right now my levels still show 0 and 10 feet here. And this is because these objects, my level objects here, are showing their height with respect to the project base point. So what I'm going to do here is I'm going to go into visibility, go down to site, and turn on the project base point. And sure enough, you folks can see that level 1 is at the same elevation as my project base point. Now, if I go into my level and click on its type properties, so if you folks select one of the levels here in your elevation view, and you immediately go over to Edit Type, you can see here that this level style gets its height from the project base point. So if I wanted to here, I could say, please show me the elevation of this level above my survey point. And once I've done that, you folks can see that these levels are showing different numbers. And that is because level 1 is now reporting its height above the survey point. And so the vertical distance between the survey point and level 1 is 193 feet and change. So here I'm going to switch my type properties of my level back to look at the project base point. Now, how do I get my level 1 to show 100 feet? Well, the really brutal way of doing it would be to select these two levels and use the move command and move them upwards 100 feet. Oh, that's a little bit heavy-handed. It turns out we don't have to go down that road. What we can do instead is select our project base point. Now, we can't just grab the project base point and use the move command and move it down 100 feet. Now, it looks like something's happened, but really nothing has happened. The project base point is still in its original position, and level 1 is still showing 0 feet. So what did happen there? Well, if you move the project base point in its clipped mode down 100 feet, it's just the very same thing as having moved the survey point up 100 feet. So folks, have a look at the distance between these two icons vertically right now. That's the way it was before I did that move. So that's what happened before I did the move. The distance between these icons was actually 100 feet greater. So moving the project base point in its clipped mode in some given direction, i.e. downwards, is exactly the same as taking our survey point and moving it upwards. So if I want my levels to show 100 feet, so my main floor to show 100 feet of the of elevation, I have to click on my project base point and unclip it. So now that I've done that, now that I've unclipped my project base point, I can use the move command and I can move it straight down 100 feet. And now you can see that the project base point has moved downwards and my levels are now showing 100 feet. So if I add some parkade stories now using the level tool, they are not going to show negative numbers. So there's my first parkade level, and I'll put in a couple more here, and you'll see of course that all of them are going to show positive values greater than 0. So that's just unclipping our project base point and moving it downwards. So for your projects, that's a great way to get 100 feet of elevation for your project. Now, what if you're working in a metric project? So what I'm going to do here, I'm just going to go to units, and I'm going to switch to meters. So what I'd like to do is I'd like to see my level 1 show 100 meters instead of 30. And actually with my units I need to increase my precision a bit here. There we go. So how would I do that? Well, what I would need to do, so instead of moving my project base point in the unclipped mode down 100 feet, I would simply move it down 100 meters. And now my first floor would show 100 meters of elevation instead. So it's just a matter of moving the unclipped mode of our project base point by 100 feet for an imperial project, or 100 meters for a metric project. Okay, so what we're going to do here now, I think we will take a break for 10 minutes. So folks, come back at 7:45 and we will carry on with the lecture. Okay folks, we'll get started again here in about 1 minute. Okay, so nobody's texted me any questions, so I guess everybody must be feeling pretty good with everything that they're learning so far. So we're going to move on to the Advanced Site Modeling PDF, which you should find in the Share Out folder for tonight. Now, most of you have probably had an opportunity to build a site model in Revit before. One of the great things about being able to model a site when you're modeling a building is that you really can respond to the site with the building that you are designing. So for me, the fact that Revit has site modeling tools in it is really quite fantastic, and some of the early versions of Revit that I used did not have site modeling capabilities in it. So when that was added to Revit, it was wonderful to be able to have the site and to be able to envision the design in situ on the site. So one of the reasons that we model the site is so that we can have a better understanding of how the building fits into the site. Now, another thing that Revit can do is that it can calculate any cut or fill that you do to the site when you regrade the site. So Revit will allow you to put in a topographic model of your site prior to construction. So you can show the existing conditions of your site, and then after that you can modify the grading to suit your building's design. So you can increase the elevation of certain portions of your site, or you can excavate certain portions of your site, and Revit will calculate the cut, fill, and the net value of cutting and filling for your project, so that if possible you can try and get to a sort of a net zero condition where you are neither taking soil off the site or adding any to it. So what we're also going to be looking at is dealing with our geodetic elevation above sea level at the same time that we model our site. So first of all, the most common way that we model the conditions of our site is by using a CAD file provided to us by the surveyor. So what we're going to do is just use a CAD file that's provided in our Session 1 folder. So I'm going to go into Revit here, and I'm just going to close down the file I had open, and I'm going to start a new blank file using the architectural template. Okay, now what we're going to do here for this example is we are going to bring in a CAD file that's provided in our Share Out folder for tonight in Session 1. So I'm going to go to the Insert tab, and I'm going to import a CAD file. So if you go into the Session 1 folder, you should find, I think it's the site plan that we're going to import first of all. So I'm going to import CAD, and I'm importing the site plan AutoCAD drawing. Now, just while we're hanging out in this dialog box here, I should point something out that's quite important. Most of the time when you get a surveyor's CAD file in, the survey has been done in meters. Now if that's the case, you should, in the import dialog box, tell Revit that you're importing what is a meters file. The other thing that you should do is uncheck this box here, correct lines that are slightly off axis. Now this is done because sometimes there are people who send you messy CAD files, and the lines in that CAD file, you know, they might be pretty close to 0 degrees or 90 degrees, but they're not quite. And so Revit will helpfully try and make those lines completely orthogonal. Now, as you probably know, property lines are often close to being aligned with north, but they might be out just a little bit. So if you're importing a survey, you definitely want to make sure that you have this correct lines that are slightly off axis checkbox unchecked. You don't want Revit reorienting the property lines in your project. So first of all, confirm the units that you're getting your CAD file in, and then uncheck the box, correct lines that are slightly off axis. So what I'm going to do now is I'm just going to leave it at auto detect, and I'm going to bring in this CAD file. So when we zoom out here, we can see the entire extent of our CAD file. The red line is our property line. So now if I go and look at it in 3D, you can see that as we use the shift button and our middle mouse button, that the polylines inside the survey all have different Z coordinates, and it's based on those polylines that Revit can build a topographic model of our site. Now, on occasion you will get a CAD file from your surveyor and none of the property lines have been given any Z coordinates. So what happens is, here you can see the property line and the lines for the building. Those are all having a 0 elevation value, and the property lines have non-zero values, so you can see they do have elevation. But you can get a surveyor's CAD file where all the polylines, there's no elevation to them, and then you cannot build your Revit topography model using that file. So you got to go up and call your surveyor and just say, hey, can you send me a copy of your survey that has 3D contour lines in it? Now, the vast majority of the cases, that's what the surveyor is going to send you. They're going to have 3D data built into their files. But if they don't, just call them and ask them if they can put that into the file for you. Now, a little trick here. Often when you get your CAD file from the survey, you don't know which layers have the topographic data in them. So here's a little trick. If you're in 3D and you can orbit around and you can see that there are some layers that have topographic information on them and some that do not, what layers are they? And you're going to see why it's important to know what layers contain the topographic data in a moment. So select the AutoCAD drawing and you'll see the query button up here on the ribbon. So what you can do then in query mode is you can put your cursor over one of the lines that contains Z data in your survey, and Revit will tell you what layer it's on. So here we've got C-topo. Those layers are containing Z values for our topography. So we know when we go to make the topography from the surveyor's CAD file, which layers we will need to use to create the topographic model. So what we're going to do now is we're going to go to the, oh, I see a text message here. Okay, the question is, what happens if a surveyor can't give you a CAD file with Z values? Well, there's two answers to this. Number one, you should fire him, because what good is a surveyor if they can't actually provide you with 3D survey data? Okay, that's maybe a little harsh, but what you can do in that case, we'll show you in a few moments what you can do if that's a situation that you run into. So first of all, here we're going to do the Toposurface tool. So on the Masking and Site tab, choose Toposurface, and inside this command, we're going to choose Create from Import. So in this menu, we're going to select an imported CAD file. So what you do now is you put your cursor just over one of the entities in the CAD file and click. So what this does is it pops up a layer list of all the different layers that are in the CAD file. Now, there's a whole bunch of layers that don't contain any topographic information. So what I'm going to do here is I'm going to hit check none. And then I'm only going to check the layers that have topographic data in them and hit OK. So now what you can see is a series of little black squares that contain the topographic model from the CAD file. Each one of these little black dots is one of the endpoints of the polyline that was put in there by the surveyor's software. So typically what happens is a surveyor goes out on site and they shoot a few hundred or maybe even a few thousand different data points of X, Y, and Z values for the site, and their software back at the office will interpolate between them and create a series of polylines. So the surveyor most definitely did not shoot all of these data points that you see here. These were created by the software to build contour lines for the surveyor's CAD file. So what we're getting here is perhaps an artificially accurate rendition of the site model. In any event, all of those little points are from the vertices of the polylines that were in the surveyor's CAD file. And now we've got a few tools to talk about here. Now, you can see that there is a Simplify Surface button. What this does when you click on it, you're telling Revit if there are any data points in a greater than 3-inch radius around, say, one of the data points, you can delete it. So horizontally it's saying if there's any data points that are closer than 3 inches together, you can delete them so that they're no more than 3 inches apart. Now that's super accurate. Really all we need is maybe 24-inch accuracy. So what that means is within any given black dot, we don't need to have any other black dots around it, say within 24 inches. That is accurate enough. So when we hit OK here, we're going to see that some of these dots are going to disappear. And that's what happened. Now, the Simplify Surface command is really only necessary if you find that you've gotten an extremely detailed survey model from your surveyor, an extremely detailed CAD file. And when you create the Toposurface model in Revit, it's really chunky. So when you finish your Toposurface model, and here I'm going to turn on shading. So if you're orbiting this model around and you find that it orbits really chunkily, like you don't get smooth rotation when you're orbiting the file, that is when you would make use of the Simplify Surface command. So generally speaking, if you don't need to use it, just keep all your data points from your surveyor and you're fine. Now while you are editing a Toposurface, so here after the Toposurface has been created, if you put your cursor on it or on the edge of it and select it, Revit will allow you to go back in and re-edit the points of your Toposurface. So there's a few things that you can do. If you're looking at maybe doing some regrading of your site, you can change some of the values of these points that are in the Toposurface. So I can select, one or more of these points, and I can change their height. So this point right here, right now, it's at 18 feet. So all of these points here are all at 18 feet. But if I wanted to create a little plateau here, well, I could just select a bunch of these points and make them all 18 feet. And so now you can see what's happened. It's created a little plateau here out on the edge of my hill. So here I'll select a few more points and change their value so that they are all at 18 feet. So here you can see the impact of having done that. Now you can also delete a few points. So you could just grab a bunch of these points and delete them, and kind of, you are sort of simplifying the data model between the points that are sort of around where you've deleted some of those topless surface points. And then of course you can place a few points of your own making. So out here, let's say I've got my building footprint. Let's say that I wanted to elevate the site by about 4 feet at my building footprint. So I put in 4 feet for the value, and now I can start placing points and elevating my building all around the site. Now you can see it elevated it above the entities in the Cad file, so that the Cad file is buried. It's underneath the ground right now. So if I switch to Wireframe, I can now see my edges of the building again, so I can continue with placing those points right close to the edge of the building. Now this is all well and good if you're getting 3D data from your surveyor. What do we do in the situation where that information has not been given to us and we've basically got a flat 2D CAD file from our surveyor? Well, then things get a little bit more tedious. Now let's just say, for example, that this yellow line here represents 0 feet, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that each yellow line here is a series of 10 feet intervals. Well, when you're building a topple surface, you can build it manually by placing the points yourself. So instead of doing what we did earlier by importing a CAD file and using the data in the CAD file to create the model, we can place those data points ourselves. So by using the Place Point tool, I can place a few points into my model over the polylines given to me by the surveyor. And if you put one in, every meter or so, that will probably be good enough to create accuracy for your model. Now what Revit is doing here is based on the points I've put in so far. As long as I've got 3 points created, Revit will start to build a topography model. So I would just go through and very quickly, or as quickly as possible, get a few of these points in. So on the other side here, I think these are at 0 elevation as well. And these polylines here I think are at negative elevation, but I'm not going to worry about putting those in at this time. So here I'm just quickly throwing in a few points at 0 elevation. Now, here I don't think I want to model them at every foot interval. I'm going to go straight to 10 feet. So basically what you're doing is you are tracing over the surveyor's topographic information and just dumping in topple surface points at different intervals to try and create a model of the site quickly, and adding those points in yourself. So not obviously the greatest use of your time, but if you do not have 3D topographic information available to you in a CAD file of some kind, this is the method that you would have to use to create that data yourself. So then I would just switch to 20 feet and go up to the next set of contour lines and keep going. So a little tedious, but it will get the job done. And in terms of having a model to look at, it's certainly better than nothing. Now, you may have a situation where you have, say, a picture or a scan of a survey and you're not tracing over a CAD file at all. You'd be tracing over a JPEG that you had put into your site plan. That's no problem. You can do the same thing here. Just place a few of these topple surface point objects over top of the contour lines from your scanned survey, your JPEG, and that will work just as fine. So I hope that answers your question. Again, really like that you folks are sending me questions as we roll along with the lecture here tonight. Okay, so with the CAD files, we've kind of talked about building those topless surface points using our CAD data. There's a little exercise on the next page here, and what you're going to do here is that instead of importing the CAD file, you're going to link the CAD file. So in Revit here, I'm just going to delete the old topless surface, and I'm going to delete this CAD file that's here. Oh, got to unpin them first. So in the exercise, what you're going to do, on the insert command, instead of using the import command, we are going to use the link CAD file command. So if any of you have done XREFs in AutoCAD, that's exactly what we're doing here, is we're going to basically XREF in a CAD file, and we're going to use that same CAD file that I was just using moments ago. So the exercise in page 2 of the notes in this file, session 1.03, advanced site modeling, just go ahead and we'll take 10 minutes, and we're going to go through and show how we can link a CAD file in using shared coordinates. So in this case we're linking it, not importing it. So go through those steps, and then we'll talk about the implications of this in about 5 minutes. Okay, so what we're really wanting to show here is how shared coordinates in Revit can be made to link with the coordinates of a linked CAD file. So here, when I link in that same CAD file that we had brought in moments ago, we're bringing it in by shared coordinates. So what's happening is that 0, 0 in AutoCAD is going to be lined up with the survey base point in Revit. So this is the note here, which is telling you that at this point the link's world coordinates, so that is 0, 0 in AutoCAD, is going to be aligned with shared coordinates in Revit, which is what we want. So what this means is that the survey point is going to be the location for this AutoCAD file. So you'll notice that if I move the survey point around, the CAD file moves with it. So that may seem a little bit weird, but the point is that if our survey point is going to be used as a point of reference, when we start coordinating locations between Revit and our consultants who are still working in AutoCAD, this survey point can really become a strong point of reference, and that is the intent. The intent is that the survey point will be used to coordinate our plan locations between all the different consultants on the team, whether they are using Revit or whether they are using AutoCAD. So really that's just the intent of that exercise, and we can move on. Okay, the next thing to talk about in our notes, and this is a somewhat rare situation, but some of you may have need of this in the future. Revit can build topographic models of your site from coordinate geometry data. Now, if you've ever heard of a total station is what surveyors use to get the topographic information from the site. A total station is a device, it sits on a tripod, and it shoots a laser sight to a prism, which is held by a surveyor. So the total station is located at a known location on the site, and the surveyor will have a little trigger that he can push with his fingers, and when he hits the trigger, the total station will shoot a quick laser beam at the prism that he's holding onto with his stick, and it will record the height of that point on the site where the surveyor is standing with his survey stick with the prism on top of it. So surveyors will then shoot several hundred or several thousand data points between a total station and their prism, and that will allow them to build a model of the site. That information comes back to their offices in a series of basically Excel values. So if you were to open up the file, you get a bunch of X, Y, and Z points, just a whole series of them in a row, and that is what the surveyor's CAD files will, or surveyor's software will use. It'll take those X, Y, Z values, basically spreadsheet data, and turn it into a topographic model. Revit can do the same thing. So inside Revit, when we're importing topographic data, so in massing and site here, when we use the Toposurface command, we can ask Revit to import what's called a points file. So this is the same file that the surveyors use to build their CAD file, but you can bring that directly into Revit. So any of you, if you've got a total station that you've got access to, Revit can deal with that data directly, and you don't have to have a survey CAD file at all. Okay, so now let's look at some of these Toposurface editing tools here. So these are the ones on page 3 of the notes. And so I guess what I'm going to do here is I'm going to import that CAD file again, just one more time here. Alright, so I'm just going to go into 3D, and I'm going to use the Toposurface tool. and this time I'm going to use the import instance option. So I've started up the Toposurface command, I've got my Cad file here, and I'm going to build my topography. And I'm going to finish. And then I'm going to switch to shaded mode. So maybe I'll give you a couple of minutes to catch up there. If anybody needs me to go through those steps again, just give me a text. I think there's about a 1 or 2 minute delay between what I'm doing and you seeing it, so there might be a bit of a delay of me getting back to you. But if you need any help just with getting the Toposurface model created again so we can use these next tools that we're going to go through, just send me a quick text message and we'll go through it again. Data directly, and you don't have to have a survey CAD file pull. Okay, so now let's look at some of these Toposurface editing tools here. Okay, so I can just see on the stream here, because I'm just watching the stream on my iPad just to make sure how the timing of all of this is working. I'm going to show these tools that we're talking about in our notes. So the first one here we're going to talk about is the Split Surface Tool. So the Split Surface Tool, you'll see it here on the Masking and Site tab. And the purpose of the Split Surface Tool, is to take a topography, or take a toposurface that Revit has created and turn it into two toposurfaces. So there might be a couple of reasons why you want to do that. Now here I am, I'm in the site plan, and you can see that I've got my property lines, and some of them are being obscured because they're underground. So the 3D lines for our lot boundaries are being hidden here slightly by the toposurface. So if I switch to Wireframe, there you go, I can see the whole thing. And if I go back to hidden line mode, those property lines are being hidden. Now, one of the main reasons that you want to use the Split Surface Tool is if you are going to be doing regrading of your site. Now here's the deal. When you start using Revit's Toposurface tools to do editing of your site's elevation, you don't want to modify any of your topography that is off your site, because obviously you don't have any permission to change the topography of your neighbor's site. So the idea with the Split Surface Tool is that you break up your topography so this entire toposurface that's been given to you by the surveyor, you're only going to be modifying the part that is inside your property line. So what you do then is you hit the Split Surface Tool, pick your toposurface, and then just use your property lines. So here I'm going to hover, tab, and then left click, and here you can see I've got a series of sketch lines, the pink sketch lines that you often see with Revit when you're creating floors. And so now when I finish, I'm going to have two topo surfaces. I'm going to have my off-site topo, and I'm going to have my on-site topo. So now what this will allow me to do is to modify my on-site topography, and whatever modifications that I do now, it's not going to affect the geometry of the topo surface that is off the site. So this is a very safe thing to do if you're going to be doing any site grading close to the property line, just to ensure that you're not going to be affecting the grading on your neighboring properties. So that is the split surface tool. Now the corollary tool here is merge surfaces. So what this will do, it will take two surfaces that were previously split and put them back together again. So now it takes those two topo surfaces that were used to be separated and puts them back together again. So that is merge and split surface. Now the next tool to talk about here is the subregion tool. So what the subregion tool does is allows you to paint a different material onto the surface of your site. Now here you can see in the center of my site I've got some roadways that are being indicated. So if we look at this with color turned on here, you can see that all of the site right now is being shown with just brown dirt. Now if you want to change the materiality of your site for rendering purposes, if you select that topo surface, you can see that it's got a material value, and if you put your cursor in here and you ask Revit to choose a different material, in a few seconds here it's going to spawn up the materials dialog box, and I'm going to ask Revit to make my site grassy. So in a few seconds here, material dialog box will appear, and I'm going to type in grass up here. Now you can see I don't happen to have any grass in my project, and actually I'm a little surprised that it's not showing me any grass at all. That's actually That's weird. I actually would expect Revit to show grass down here, because I know that that there is grass in the library. Folks, yeah, and the question is, you'll be able to watch this video again anytime you want. If you go to youtube.com/Wes Macaulay, you will see this stream in here again, so you'll be able to come back and review this at a later date. So normally, yeah, I would expect to see grass in this list and I could bring it in. Unfortunately, I can't do that. I'll just show here gravel, and I can import gravel into my site. And now this gravel material will be used instead. And so now you can see the material is gravel. So you can see now it is gray. So again, if you want to make your site have grass, you can just go into its material parameter here. Yeah, that's really weird. Well, I'm not going to worry about that right now. It could be just because I'm streaming and all my resources are being used to stream this out onto YouTube. So that's how you bring grass onto your project. Now, if you want to now take some of the area of your site and indicate it as pavement or asphalt or grass, the subregion tool will allow you to draw an area of your site. And once you're done, you'll be able to select that part of your site and change its material. Now there, I just use the subregion tool, and I just use the drawing tools to manually draw an area on the site. Now I can also use the pick tool. So here I can use the pick tool, put my cursor over one of those AutoCAD lines, hover, tab, click. So here I'm going to grab these lines as well, hover, tab, click. Tab, click, tab, click, and finally one last one here. Now, just like any sketch in Revit, for this sketch to be valid, it has to be closed. So that means down here I need to just draw some lines over the openings here just to make sure it's a closed sketch. So now that this subregion sketch is closed, I can finish. Now, some of you might notice that my subregion actually runs off the edge of the topo surface, and Revit doesn't seem to care about that. So I can hit finish here, And now, again, I've got a separate region, and let's say that I want to show this as asphalt. So what I can do now is I can go up into the material palette here, and I can type in asphalt, and there's our asphalt pavement. So now I can import that into my project. So here we can see a little rendered preview of what this asphalt would look like. So now when I hit OK, now I've got black roads around the where I've got my walls, or where I've got my roads. So this is the subregion tool. Now after you've created a subregion, you can click on that subregion and you can hit Edit Boundary. So this will allow you to go back and change the shape of the subregion if you need to do so. Now once a subregion has been created, you can just simply select it and delete it. And that will remove the subregion altogether, but your topography will still be preserved. So subregions are just an area that you draw on your topography so you can have a different material shown, sometimes for doing site planning purposes like drawing roads. But more than anything, it's meant for rendering purposes, so that once you have a camera looking at this part of the site, you know, you've got some cars placed on here, the area underneath the cars will render as asphalt instead of rendering as grass or gravel or something else. All right, moving on. The graded region tool, I think what I'll do is I'll hold off on talking about that until next week. The purpose of the graded region tool is to do that calculation of fill and cut and the net difference between cut and fill on a site, so that you can calculate how much soil you need to take from or add to the site. Now, someone's noticed that the subregion didn't go beyond the property line here. Now if you look at the sketch, you can see that the subregion did go beyond the edge of the property, but nothing happened. Now why is that? Well, the reason is that these are two different topo surfaces. I used a split surface command and I made these into two topo surfaces. Now if it was just one topo surface that I had here, when I did the subregion tool, because the subregion spans over that entire distance here, if these were both merged into one topo surface, then my black roads would show up over all of the area that I've shown, and not just part of it. And the reason is that I started drawing my topo surface on top of this one topo surface here. So this subregion was drawn on this first topo surface, and so it only affected it. Good question. So I'm going to save a graded region for next week. All right, contour labels. So what these work with is with the contour labels that Revit creates when it builds a topo surface. Now you can see the green AutoCAD lines in the background. Those do not assist in helping Revit create these contour labels. So let's look at what happens. So on the Masking and Site tab, here's your contour labels command. So what you simply do is draw a line across the screen, and Revit puts on contour labels following that line. Now after the line has been placed, you can kind of click on these contour labels, and you can see you can grab the endpoints of that contour line and move it around. So you can draw these things anywhere. So Masking and Site, label contours. So I can draw a few there. Any place that you can see contour labels, you can draw this tool or these annotations across the screen. Now, you can ask Revit to only label your primary contours. Now here you can see you've got some secondary contours. They've got a lighter line. And then you've got primary contours which have a heavier line. So with the contour labels annotations, so again you can see the endpoint dots here that you can just drag around. But if you go and look at the properties of this contour label, edit type, I can ask my contour labels to simply only label my primary contours. So now you can see that it's only putting one of those things in every 10 feet. Now, why am I only getting primary contours every 10 feet? Well, that is controlled in a very hard to find dialog box. So on the Masking and Site tab, on the Model Site panel, there is this little arrow. And so when I go to the Masking and Site tab and I find the Model Site panel and I click on this little arrow, it brings up this dialog box right here. This is the Site Settings dialog box. And this is the only way that I know of that you can get at this dialog box in Revit. So, what this dialog is about, it's about setting the intervals at which we see major and minor contours in our project. So at the top here, contour lines at intervals of 10 feet. So these are our major contours. So here I can switch this to 5 feet, and now we're going to see major contour lines every 5 feet instead of every 10 feet. And there you can see the impact of doing that. And so now underneath this, you're telling Revit when you want secondary contours to be displayed. And you can set the starting elevation and the stopping elevation for when you want these contours to appear. So I could say, hey, you know what? I don't want these to start until 15 feet above sea level, and I only want these to go up to 30 feet above sea level. So within this range, between 15 and 30 feet, that's the only time you're going to see these contours. So keep an eye in the background here. Now what's happened is you can still see the AutoCAD drawing is still there with its contours, and I'm just going to turn that off. So I'm going to go to Visibility here, go to my Imported tab, and turn off that AutoCAD drawing. So again, you can see what's happened. So if I go back to my Site Settings dialog box, so go to Masking and Site, and go to the Model Site panel and click the little arrow. From 15 to 30 feet, I'm getting my secondary contours. So I'm going to make that 5 to 30, and you can see what happens, or from 10 to 30. So what's the purpose of this? Well, the purpose of this is that you might be building on the side of a hill, and the project that you're building is just within this band here, say between 15 and 25 feet. So you're not really interested in showing all those secondary contours in elevations that don't relate to your building. You're only showing those secondary contours in elevations that relate to your building. So you're only going to show the secondary contours in that zone. So that's what the purpose of this dialog box is. Okay. Okay, so that was contour labels. We're going to talk about building pad objects now. Now, the building pad object, what that does is it creates an imprinted or a recessed area in your site so that you can put in a basement. So here what I'm going to do is I'm just going to say that it's maybe 10 feet above level 1 here, and I'll just draw an area here where I'm going to indicate that I want an area cut into the side of the hill here for my building. And so when I'm done, you can see the impact here, and if we go back and look at it in 3D, and I guess I'm just going to turn off my AutoCAD drawing here again. There we go. So here you can see there's the building pad object here in this location, and you can see that it creates a hole in the site. So basically you would draw that around where you've got a basement in the site, and it'll just cut the dirt out of that location. So that is what a building pad object is meant to do. Okay, we've gone through the Site Settings dialog box here, so you folks know about that. Have a look at the graded regions description on the next page here. We're going to talk about graded regions and phasing in the next class. So just have a look at that right now, and then we're going to discuss that in more detail. Now what we're going to get into right now is a process or a technique that we will use to deal with our site model and with our building model. Now this next bit of the lecture is a little difficult, I guess, to understand initially, but I'll try and explain it to you starting now. Now, when we're looking at our Revit models, we've already talked about project coordinates and shared coordinates. The levels in your project, if we go to their properties, their type properties, we can ask this level to report its height above the project base point or above the survey point. Now, if you remember earlier when we were talking about setting up your Revit project, we wanted to have our project's main floor at 100 feet or 100 meters if it's a metric project. Now, of course, that 100 feet or 100 meters does not relate to the height of the building above sea level. It's just a relative elevation that we use for convenience's sake. So, what we've done is we've used the project base point, unclipped it, and moved it down 100 feet or 100 meters, depending on the units that we are using for our project. But again, this has nothing to do with the height of our building or the height of our site above sea level. So we'd end up not using the project base point to deal with the height of our site above sea level. So remember, the project base point is used by Revit's coordinate system that's called project coordinates. Now, here is the problem. The survey point, and therefore shared coordinates, are used to show or represent the height of our project above sea level. So in our elevations here, our levels will not show the height above sea level because they are using project coordinates. They are using the project base point icon to represent their height. Now, let's go to 3D here. Our topo surfaces, when we look at the value of those little black points that you see inside the topo surface, so all these little points here, the elevation value that it's giving you here is in project coordinates. Now, what's the implication of this? If our points in a topo surface cannot be made to relate to shared coordinates, then what is the height of this dot above? So this little 6-foot value that you see here, that means that this little dot is 6 feet above the project base point. So in the end, it means that to have our main floor at 100 feet, that's a relative elevation. The main floor is looking at project coordinates. Unfortunately, your topo surface points also look at project coordinates, and there's no way that I know of yet to get these little dots that represent the heights of our topo surface to relate back to shared coordinates. So this ends up being a huge problem for us when we're trying to have our floor at a relative elevation that's convenient for us of 100 feet or 100 meters. So we've got to come up with a workaround. And the workaround for this quandary is to build the site in a separate model than the building. So what we're going to do is build the site in its own file, build the building in its own file, and then link them into each other. So let's look at what this is about. So in our session 1 folder for tonight, we have a couple of files that we're going to use to help us understand this process. I want you folks to look at house project-site and house project-building. These are the two files that we are going to be working with as we talk about this whole new solution of having a site in its own file and the building in a separate file. Now first of all here, I'm going to open up House Project -Site. Okay, so when you open up House Project -Site, you're going to see a section view that shows the lay of the land. Now, here's how the process works. When you get your CAD file from your surveyor, you link it into a blank Revit project. Just link it in or import it in, it doesn't matter which. Bring in that imported CAD file and create your Toposurface from it. Pretty straightforward. There's nothing fancy that you have to do. You don't need to move your project base point. You don't need to move your survey point. Everything just sits as is. So you start with a blank file, import your CAD file from the surveyor, and build the topography. And so you'll end up with something like this. Just a piece of dirt, just sitting there. There's a little sub-region that's been added for this driveway here, but you might not, of course, have that at all. So once you've got your site model built and the topography has been created, you'll see all of your polylines for the all your contour lines rather for the Toposurface. So here I'll just turn on shading so we can see. So we've got green grass and we've got a little bit of asphalt at the back. So now what we're going to do is we are going to link in the building. So I'm going to go to the Insert tab now, and I'm going to link in the building. So I'm going to go down and find House Project -Building, and I'm just going to hover here for a moment. So when we link in the building into our site, we're going to start making use of Revit's shared coordinates system. So before I hit OK to link in my house project, the building model, I'm going to switch to shared coordinates. So what this means is Revit is going to try and align the shared coordinates in the site with the shared coordinates of my building. Okay, so now I'm just going to hit open. Now we're going to get this upgrade notice just the once here, and then everything's going to be okay. Now, this notice here is basically telling us that these two files are not actually sharing their coordinates. So we're using shared coordinates, as it said in the import dialog box when we brought in this Revit file, but Revit is telling us that no, these files are not sharing their coordinates yet. So whatever. So what happens now is you can see that the house has been brought in, but it's underground. So what we're going to do is go back to our section here, and you can see that our house is indeed underground. Now what I'm going to do is I'm going to switch to Wireframe so I can see where my house is sitting. And I'm just going to use the arrow keys, if you can believe it. So I'm just going to click on my linked house, and I'm going to use the arrow keys to nudge it up above the ground. A little bit more here. There we go. So it doesn't matter exactly where you've got it. What you want to confirm is that when you go back and see it in 3D, that the house is indeed sitting above the ground. There's a little entrance to the basement here. You want to make sure that the steps outside are you know, at least above the ground. So even here in 3D I can work this up. So here in 3D I can select my linked house model, and I'll just use the arrow keys and I'll just tap it down a little bit lower so that the steps are just above grade there. That's good. So I've got my building roughly where I want it. Now that I've got my building in place, when I select it, there's a little dialog box over here that says shared site, not shared. So the idea with shared coordinates is that when we link our Revit models together, that we can get them to be on the same page. So what does this mean? That their shared coordinates are all pointing in the same direction and are all at the same elevation. So what I'm going to do is I'm going to hit the button here, not shared. Now, I have two options here: publish or acquire. Now, what is this about? Well, what this is about is moving the survey point in one of these files so that the survey points in these two files are in the same location and that the coordinate systems are pointing in the same direction. So what this is basically doing is making Truenorth happen and getting them both pointed in the same direction in both files. Now, I'm just going to go back to this section here for a moment. Down at the bottom here in this section, you can see that the survey point and the project base point are both turned on. I'm going to go into the site category here in the section, and I'm going to turn off the project base point. Because what we're really talking about doing here is getting both the site and our building so that the survey points are in the same location in both files. This survey point represents sea level. And here you can see that the survey point is quite a bit lower than our house. It makes sense. Our buildings are usually several feet or several hundred feet above sea level. So what we did is we linked in our house and we manually moved it upwards so that we were essentially making the survey point lower with respect to our house because we took the house and we moved it upwards. So right now, if I were to look inside my house file, we would find that the triangular icon, the survey point, is probably right up at the main floor or at the basement, somewhere around where my cursor is right now. So at this point, the survey point in my house is not down here. It's up here somewhere. Now we just can't see it when we link the building in. But what happens when we select on this linked building here in the site and we go to the shared site dialog box? Well, now we're saying to Revit, if we choose publish, it means that we push the location of the survey point as it is here in our site and make our linked house align its survey point with the one that's here in our site. And that's what we want to do. Now, if we hit acquire and hit reconcile, what would happen is Revit would basically tell the site, hey, find where the survey point is in this house and move the survey point up to it. But that's not really what we want. We want our site to sort of drive the bus with respect to where sea level is. So we're going to choose publish. Now, of course, Revit's not going to let us do this until we've upgraded our house model. So that's fine. We'll just hit cancel for now. So what I'm going to do is I'm going to hit save. So this is going to upgrade this file to the 2018 file format. It was in the 2017 file format before. Alright, so I'm just going to close this down. And now I'm going to go to the open dialog box. And I'm going to take my building model and I'm just going to open it up. And all I'm going to do is open it so it gets converted to Revit 2018 file format and save it. Oh, you're saying, you guys, I got disconnected from the big screen. Okay, just a second here. I'll wait. Okay, just doing a test here. Testing, testing, testing. 1, 2, 3. Okay, we're back online again. Great. Okay, so all I did was I opened up my house project, my building file, and all I'm going to do is just save it. So we're back in the 2018 file format here. So I'm just going to go to File and then Save. I thought I'd done this already, but just because I'm off-site, I'm hard to say here. Maybe something's I've just got the wrong files here at home. Okay, so now that I've got my site model in the 2018 format and my building model in the 2018 format, we're good to go here. So I'm just going to close my building model down, and I'm going to go back to my site model. So now what's going to happen is I've got my linked house in, which is in the 2018 format, and I'll go back and click on it. Now, if there's something that you folks think I'm missing, maybe what I'll do is here, I'll go back and just start from scratch, just in terms of the linking business. Okay. So what I'm doing here is I'm going back to scratch and just showing how we do this linking business. First of all, starting with our site, we've got the CAD file linked in. Oh, okay, someone's sending me a picture where we last ended off. Okay, let me see here. Oh, okay, publishing coordinates, great, okay. Okay, so I'm going to go to Insert, Link Revit, bring in the building by shared coordinates. There it is. It's in the wrong spot, so I'm just gonna use the arrow keys and nudge it up into place. So this is where we left off. Now, because I have upgraded my house file to the 2018 file format, everything's going to work perfectly from now on in. If you folks are having trouble with getting this whole linking business to work, just later offline, just open up the house project building file and just open it up and immediately save it so that it is in the 2018 file format. So I'm just going to go to 3D here and just make sure that I'm happy with the elevation of my house, and I am. That's exactly where I want it. So now when I select my house, this is the dialog box that we got left off at. Publish or acquire, and I'm going to go into my section here and just talk about that again. So if I choose publish, what this is going to do is take the location of the survey point and make sure that in the house its survey point is going to be in the same relative location. That's what we want. So what this will do is it will do a quick write into that file, and it's going to modify the location of the survey point inside my house. And that's good. So basically what's going to happen is shared coordinates in my linked file have been modified. So what I'm going to do now is I'm going to close this file down, and Revit's going to give me a little note. You have changed basically shared coordinates in your house project. What do you want to do? I want to save it back. Well, now what? Well, now we can basically do circular referencing. Now, you folks know, if you're an AutoCAD user, if you link file A, if you XREF file A into file B, you cannot then turn around and XREF B into file A. That's called circular referencing. AutoCAD won't do it, but Revit will. So now what I'm going to do is I'm going to open up my house, and right now you will see that when I go to 3D, no site. Site's not here. But now I'm going to link it in. And because we set up shared coordinates when the house was linked into the site, when we link the site into the house, it's going to end up in exactly the right location. Check it out. So Revit just brought the site right into the exact right spot with respect to our house. Now, what happens if, for whatever reason, we need to move our house to a different location on the site? So as I was telling you before, it's easier to move the mountain than it is to move Mohammed. So what we're actually going to do here is I'm just going to close this down, and I'm going to return back to our site model. So here in the Revit desktop, I've got my site model there, and I can open it up. Now this is where linking your building into the site is awesome. It makes things really easy for you to set up your site. So I'm going to go to my site plan here. So here's the house. So what I want to do is relocate it on site. And the owner has decided that they want to change the aspect of the building a little bit so that it looks a little bit more to the south from their front door. So you'll notice here that as soon as I move my building on the site, so I've opened up my site model, and here I'm looking at my linked building. Revit is saying, hey, do you want to update shared coordinates in this linked file? So I'll just hit OK. Now I'm going to use the rotate command, and I'm going to rotate this building 10 degrees clockwise. So now you can see that the building has a new orientation on the site. It's a bit rotated. Now also too, it's a little bit too low, so I'm just going to use the I used the view cube and just picked a front face of the view cube. It wouldn't matter which face. And now I'm just going to select my linked building, and I'm going to use the arrow keys to nudge it up, just to make sure that my front steps are out of the ground. And there we go. So that's good. So here you can see the building has been relocated, it's been changed in elevation, and it's been rotated on the site. So now when I hit save here, Revit is also saying, hey, do you want to go back and change the location of the house and change its shared coordinates? And yes, you do. So you hit save. So now I'm going to close the file, and I'm going to go back and jump into my building file now. And what you're going to notice is that the site is going to appear to have been rotated in this file as well. So sure enough, look at that. The site's been rotated. Now here's where it gets even better. When it's set to Project North, you can see how our site plan is shown. But when we switch to Truenorth, look at that. It automatically rotates our house into the correct orientation. So linking your building into a site model solves a number of problems. Number one, it solves the whole Project North, Truenorth thing for your project. So what you can do is you can create a model of your site in its own file, link your building into it, and place it, rotate it, and change its elevation as required. Then when you publish coordinates from the site to your linked building model, then it will automatically set the shared coordinates in your building. It'll set it up to suit your site. So therefore you'll have your proper true north orientation, your proper geodetic elevation above sea level with respect to your survey point icon. And so it means that you can now start referring to the height of parts of your building above sea level. Yes, and the question is, the building pad would be placed in the site model. That's correct. Because if you build the pad in with your building model, that pad cannot modify the topple surface that's in a separate file. So once you've got your building into its correct location in your site model, build the pad in the site model. So the building pad object will be built with the site and not in with your house or your building. Good question. Excellent question. Okay, so the different terrain modeling options here, we've talked about option 1, and even if I'm doing just a simple house project, this is the method that I will use. So even for the smallest little single family house, if I've got a commission to build one of those up, I will use 2 separate files for this reason. The other 2 options are discussed there, but we're not going to go through with that. So if you want to go to page 7 here, just make sure that you've had a chance to go through those different options there. So I'll give you folks about 10 minutes to think that through. Keep your questions coming through to my cell phone here. I've had about half a dozen already tonight. It's really great that this has worked out. And again, this link will be on YouTube. I'll send you folks an email after tonight with the URL to this session, and it will stay up on YouTube for the duration of the of this course. Okay, so I'll give you another 5 minutes just to review the process here based on the notes on page 7. Someone's asking if they can't select True North for orientation. The only way that True North can be selected as an orientation is if you are in a plan view. If I'm in a section or 3D view, I don't believe that you can choose a there's no option for True North or Project North in 3D views or in section views. True North and Project North are only settings available in plan views, and that is under the orientation parameter. Okay folks, what we're going to do here is we are going to move on to the exercise on page 9 of the PDF. So here we're going to be using the graded region tool, and we're going to be doing some modifications to the grading to suit our site. So let's just go over and have a look at page 9 of the PDF, and we're going to walk through the process of this exercise. So editing toposurface points. So as we said, toposurface points report their elevation in project coordinates. And relating that back to sea level. Now someone has just noted, and correctly as well, that this building that we're working on right now we do have one level in this linked house that we've got that has a negative elevation. And so one of the things that we didn't do in this building model for our house was to unclip the project base point and move it down 100 meters. I just didn't bother doing that for this exercise. So if I wanted to make level 1 of this house 100 meters, I would simply go into that file, the file for my house. I would find the project base point. I would select it and hit the clip icon so that I can unclip the project base point, and then I could move it straight down 100 meters so that my level 1 would show 100 meters instead of 0, and I wouldn't have any of the levels in my house project showing a negative number. So that's how we would solve that particular question. Now, because we are linking our building into the site, project coordinates and shared coordinates are going to be at the same elevation in our site. Because of that, our toposurface points, the little black dots inside our toposurfaces, those will in fact relate back to sea level. So that also solves that part of the problem. So what we're going to do then is we are going to go back into the 3D view inside our site project. So here you can see the house is being linked in, and now I'm inside this file, and we're going to start modifying the grading inside this file. Okay, so the first part here is we need to go into a 3D view in our site file and orbit around so that we can see the patio here. So what I've done is I put a little spot elevation right on my linked house model. So I'm just going to zoom in here. So this is the location we're talking about. And from the Annotate tab, I'm going to grab the Spot Elevation tool. So once I've got that tool added here, I'm going to uncheck the leader command so that it will just put that thing right onto my cursor. So what I'm just going to do here is I want to get the elevation of the and here I'm just going to do it to the lower part of my little floor object here outside my front door. So 59.04 meters. Now that's going to be a little bit different than what we've got in our exercise, and that's okay. So what we want to do is we want to do a little bit of regrading around the site here so we can bring the lawn up to this elevation around the building, and also provide a little bit of a nice flat area around the outside here. So we're basically going to do a little bit of regrading outside the basement door. Now this is going to make use of Revit's phasing capabilities, so we can look at a project at different points in time, and we're now going to make use of the graded region tool. Okay, so step 2. Before going on to the next step, select the topple surface and edit the phase created setting and set it to existing. The color of the topple surface will turn gray. So this is what we're doing. We're going to select the topple surface. So you'll see here, just select it so it turns blue. And we're going to change the phase created from new to existing. And once we've done that, it turns gray, just like you can see here. So then the next thing, from the Masking and Site tab, choose Graded Region and choose to make a site exactly like the existing one. So going to Masking and Site, and I'm using the Graded Region tool. And so we want to create a topple surface just like the existing one. If you choose perimeter points only, what Revit does is it deletes any topple surface points within the interior of the site and just maintains a meet condition all the way around and basically nukes all of the topple surface points on the interior of the site. So we definitely don't want that. So once I've hit the Graded Region tool and I've chosen exactly like the existing one, I then pick my topple surface, and there it is. We are inside the new topple surface, so we can now begin to make edits to it. So now Revit puts us inside the newly created topple surface so we can edit it. So now, step 4, go to the site plan and switch to Wireframe. So I'm going to go to the site plan and I'm going to switch to Wireframe. So that's the next step. So go back to the notes again here. So here it says, add points with height 0 meters relative to surface. Add points, height 0 meters relative to surface. So you can see there's a few points down here I'm going to delete, and I'm going to add these points that you see here, and let's look at how that works. So these points here is what Revit wants deleted, or the notes want deleted. And now when I place points, you can see that I can either choose absolute elevation or relative to surface. So now it's relative to surface, it says 0, and I just got to find out where those things need to be placed. So a few along the edge here. Okay. So just like that. I'm just adding a few points along the edge. And now what's the purpose of this? Why am I doing this? This is so that I'm maintaining the existing lay of the land. We're going to be adding a few more topple surface points in here to suit the elevation of our project, but we want to first of all have a few existing points here, or a few points that we're putting in that will hold basically the previous elevation of our site and keep it as is. Okay, so I deleted those points. And now I've got to add a few more points. So it says 6 points as shown, 60.5 meters absolute elevation. So that's these here, 1, 2, 3, 4, 5, 6. So I'm just going to zoom in a bit here so I can see a little better what I'm doing. So those two are at 58.7. These 6 here are at 60.5. Okay, so place point 60.5. Alright, so they're going to be in this vicinity here. Whoops, not that one. Just right up to the face of this wall here and then along the edge of the building. And then points at